Redis, for those who are not familiar, is an in-memory key-value data store. It's super, super light and fast. It has all kinds of interesting widgets and doodads. And I highly recommend you folks here to take a look at it, open source, of course. But it has limitations. The key limitation is that it's memory resident, which means if your data set is bigger than memory, you have a problem. Let's do a little math exercise. Remember I said the general data access pattern, or is often referred to as a Pareto distribution, where 20% of your data is hot and 10% of your data is cold. So let's say, and so what you want is your hot data to be as readily available as possible. So presumably you might want it in a cache. Let's think about this for a second. Let's say you had 10 terabytes of data. 20% active at any given time is 2 terabytes. Do you have a machine with 2 terabytes of main RAM? Probably not. And if you did, that's very interesting. I'd love to hear about it. But what you really need is you need a farm of 2 terabytes of memory. And so as soon as you farm Redis, you need a way to shard and distribute information to all that stuff. So we heard customers who had this problem, and we worked on ways to solve this. So we created the Azure Data Platform, which Redis is a major component of. This is more or less what the architecture looks like. You have a bunch of computers. You put the Azure-provided service manager on each of the computers' servers. And then the service manager can deploy software to a particular machine in this cluster of loosely affiliated machines. Some of them can become RIAK KV installations. Some of them can become Redis. Some of them can become Spark. The one at the top is the cache proxy. So the service manager itself is an early process that monitors other processes. So think of it as like Forever or Supervisor D or God. These process monitors that do these things. But you get the speaker to like turn his phone off. He's the worst. Okay, so this is kind of a tree diagram of what this looks like. The service manager running a leader election piece, which is specific to Spark, and I'll talk a little bit more about that later. But the Redis piece itself, this is what it looks like from a diagram perspective. All of these nodes are running kind of service manager. You have some clients sitting outside of it. It's the guy on the right. The one in the middle is the one running the cache proxy. So what we've implemented in the initial version of our BDP product is a read-through cache. You write your data to RIAK, you read your data from Redis. The next version of this will be a write-through cache. This version is a read-through cache. The next version will be a write-through cache where you can read and write through this proxy. But what this allows you to do, for any of you folks who've run Redis before, you know that Redis has a BG background, it's known as BG save, background save, which basically what it does is it forks the process and F-syncs the entire memory dump to disk. This is cost. There's a cost associated with this in terms of availability of the process to make this happen in time. How long does it take to get this done? So the more memory you have allocated to Redis, the longer it takes to do these things. So these are all kinds of considerations that you have to take when deploying Redis. So what we've done is said, forget it. We're going to run Redis minus disk. We're just using RAM. It's purely a cache. And what we're going to do is we're going to use RIAK, which is a persistent database, as the on-disk backup. So when your Redis machine dies, and it probably will at some point, the cache proxy will recognize that there's a cache hit miss, a cache miss, and then go to RIAK, backfill it, deliver it to the client, and populate it in the Redis farm. So this is how this whole thing gets put together. This is a little bit of a diagram of how that works. Of course, all these slides will be available, so I won't get into the minutiae here, but stuff works. And why would you want to do this? It's because internally we've tested this, and if you can get an 80% cache hit rate, you can improve your read performance by 5x. Now, of course, this is completely dependent on your use case. Do you have a use case where your data is being rapidly accessed? The same set of data is being rapidly accessed. So these are some of the things that you need to think about when deploying these kinds of solutions. But
Actually, Sasha, why don't we touch on time series briefly, and then take a couple questions, and then Sasha and I will be, after we take a few questions out of respect to the next speaker, Sasha and I will be outside for 20 or 30 minutes to answer questions. So let's touch on the time series, we'll take a couple questions, and then Sasha and I will be outside, and we really appreciate everyone's hospitality of being here today. Thank you very much.
yeah, thank you all. I really appreciate the time. I also want to acknowledge the hosts who put this together, Robert Hack and Company, was able to make this happen. I mean, it's really interesting to get these many people out, computer people no less, out on a weekend. So I'm certainly surprised to see it, but thank you all for coming. So integrations, where the things that we don't do, we will integrate, or we will build. So RIAK time series is something that's new in the system. It's a little bit later on in this deck, but Spark. Spark is very interesting, by the way. For those of you whose business it is to build SQL reports, learn how to build Spark reports. You know, like SQL, structured stored procedures and things like that. Spark is taking over. It's like the MapReduce 2.0 heir apparent type of thing. So spend some time getting to know Spark for sure. We integrate with Spark as well as we integrate with Redis. From an operations perspective, our service manager can deploy these products. So you don't have to go out and install it yourself. Basher's going to do that for you. And it's part of the things that we've learned in conversations with all of our customers, the operational consideration and how we can make that easier. So we can do that. And there's a particular reason that Spark is being leveraged in that case. Master high availability Spark requires Zookeeper, and for a lot of customers, Zookeeper is a pain to deploy. So we can deploy minus Zookeeper when we have an internal component that acts as if it were Zookeeper for the specific piece that Spark needs to do that. I'll talk a little bit about time series as I wrap up here, and I'll leave you with just some of our customers, some of the people who actually use us around the world. And one of the big names, I don't even know if it's on the list, but there's a company that was recently purchased by IBM, the weather company. So these guys, major customers of ours, and you can imagine, how do I get the weather, right? How do I collect the weather? So I might have weather sensing devices globally distributed. So this is now an Internet of Things problem, where you're collecting weather measurements at a particular point in time in a particular geographical location. So this customer and others were some of the key reasons that we decided to take the time series approach. And what we did with time series is we built time series ourselves, leveraging some of the high availability, fault tolerance stuff that I've already talked about to bring to market a time series specific solution. And there are two key things that make time series time series. The first is data co-location. So remember when I said you might take the consecutive keys 1 and 2, or let's say the times 1201 and 1202, and put them through the SHA, and the SHA will put them wherever it wants. That's kind of an anti-pattern to time series, because time series wants those keys, 1201 and 1202, to be in the same place on disk. Particularly so you take advantage of sequential I/O and you don't use random I/O. And that leads to the second reason, the second thing that makes a time series database a time series database is efficient range retrieval. So those were two things that we had to tackle, and we were successful in doing that. And our time series release has been announced and is going to be imminently released in the next week or two. Keep an eye for it. So if you have time series specific use cases, I highly encourage you to take a look at this solution. It will allow you to break the constraints of housing all of your time series in a single monolithic kind of system. Leverages a lot of the distribution in the RIAK product to do it. And we're able to do sequential, serial co-locality of data and efficient range retrieval. We benchmarked this internally into the tens of kHz. We're currently at like 60 or 70 kilohertz, which is 60 or 70,000 writes per second. But our internal goal is beyond that. We're internally looking to reach 10 megahertz or 10 million writes per second, because that's what it's going to take to accommodate some of the Internet of Things use cases that are coming down the road. And with that, I guess I'll open it up to questions, and I really appreciate your attention. So thank you very much for coming, everybody. Yes?
You mentioned that you mentioned open source in this. My question is the underlying technology is, of course, open source. I mean, you mentioned all the words necessary there. But is your product itself open source, or if not, is it extensible for people to be able to add their own wristbands, for lack of a better word, to it?
Yeah, so the question has to do again with open source, and are we actually open source and or extensible? And the answer is yes, we are open source. You can go on GitHub right now, github.com/basho, take a look at all our products. All the code is there. The client libraries to access that code, also open source. Yeah, I encourage you to take a look. We take pull requests, so please send them to us. The system, again, is written in Erlang. There are various opportunities at an application API level to integrate with some of the hook points that we made available. But beyond that, we have many customers who customize the system to their specific use cases. And Basho, the company, offers full service professional services. We can help bring experts into your organization to talk about how exactly to do that. So some very large financial organizations have particular considerations, and we've been able to help them do that, among others. Yes, sir?
Yeah, what type of work do you folks do in the healthcare field?
Our biggest, so personally, I was in healthcare, and I used it, but nothing I do really matters. But the NHS in the UK, for those of you familiar or have ever had the opportunity to go over there, they do things a little bit differently over there. Single-payer system, the National Health Service of the United Kingdom controls the horizontal and vertical of what happens in healthcare. They had an initial system called Spine version 1 that was built on Oracle. Oracle couldn't do two things. One, you couldn't give them money to pay their employees. Two, because they cost so much money. Two, you couldn't meet SLAs for multi-data center replication. So they ripped out Spine version 1, they put in Spine version 2, which is based on RIAK. And what the system actually does is it inbounds data over the HL7 messaging protocol, which is a health level 7. It's a healthcare specific messaging kind of serialization and transport layer from all of their satellite hospitals, Edinburgh, London, all these things. So let's say you're a patient, your primary care physician, your PCP, or your GP, general practitioner, offers you a prescription. The prescription goes to Edinburgh. It's housed there. But you travel to London, you need to get that prescription filled in London. The filling mechanism doesn't call out to Edinburgh to get that information. It goes to the central database, the Spine version 2, where all this data is living in a RIAK-backed system. And the NHS and the UK is not the only government-level institution to use RIAK to do this. So we're working with Japan, and Denmark's also online. Those are some of our key healthcare plays.
Is it mostly global, or do you do in the U.S. also?
We also have a number of people in the U.S. as well, but of course, they're not as big as the use cases that I just mentioned. Mostly in the U.S., we were spending a lot of time with third-party companies that service pharma and also insurance companies. So here, hospitals, although they own the data, they legally own the data, they're not the tech, they don't write the tech that does those things. In some of those other places, they both own the data and are able to write their own tech. So this is what I found to be some of the differentiation between healthcare movements in the States versus healthcare abroad. Additionally, in the States, you have startups. So a lot of startups are looking to solutions like this to back end the solutions they want to provide on a large scale to customers. Thank you for the question. Yes, sir, in the back.
You mentioned one of your clients was using 100 physical. Why wasn't he using VM, and are you anti-storage, something like Cassandra? Or basically, is this a replication and a HA aspect? That's why they're going into storage.
So the question is around one of the comments I made earlier. A customer was using 100 physical nodes in a RIAK cluster, and the question was around why physical versus virtual. Is that fair? So I'm going to say this right off the bat, and no offense to any people who work for VMware. Physical will always be better than virtual. Period. And storage, there's no way around it, because what is virtual? Virtual is an abstraction over the physical. And when anytime you abstract, you implement overhead. And VMware is, you look into some of the paperwork that VMware provides, and you'll see that to be the case. There's no question about it. So for this particular customer, they wanted physical machines. Having said that, RIAK itself is an application that installs on Linux and other Xnix variants. So we have many, many successful customers who operate on internal private VMware ESXi clouds and others flavors, and also other places like Google Compute Engine, AWS EC2, Software, et cetera, et cetera. Yes, someone do. Yes, sir.
Do you guys have any plans in the future to use Elixir?
So the question is around plans to use Elixir. Elixir is a modernization that uses the Erlang virtual machine. It's a modernization language similar to something like a Scala or a Clojure that is a new type of language that uses the JVM. So we have certain subcomponents, non-core product, that we're considering Elixir for. For example, a GUI slapped on top of the RIAK cluster. We're looking at potentially writing that in Elixir, but we don't have any concrete plans. But I know a lot of people who work for Basher are very, very closely connected to the Erlang community, present at Erlang Factory all the time, every year, know all the key players in the Erlang world, and Elixir has gotten a lot of attention. So if you're in the Erlang world and you're interested in some of the modernizations, Elixir is a great opportunity. Yes, sir.
There's an interesting discussion that happened, I think it's a Cassandra session where they had Rick Ransom, infrastructure engineer from Instagram, who talked about moving from Redis into Cassandra and Zookeeper, and how it made their life 10 times easier. Again, no ring shall rule them all. The argument would come in hand here. But how would that, my interest is, why do they pick RIAK for that matter, or go with the Basher or the Zookeeper?
Yeah, well, so I'll tell you, so what is my day-to-day? What do I actually do at Basher? I'm the solutions architect, and I run around the country and I speak to customers about how to solve their problems with our kind of technology. And beyond that, it's also a conversation about bringing legacy institutions out of relational and having them at least consider non-relational solutions, of which there are many. Hadoop and RIAK and Cassandra and Redis and so on and so forth. And they're all very kind of fragmented. They all do different kinds of things. I can tell you, we are always competing against Cassandra. We're also competing against Oracle. We're competing against Mongo. So from the sense that the pie is growing, everybody's getting fed. But when it comes down to it, there are particular reasons why one technology might win over another. And one of the things is Erlang was Java. It's written in Erlang, Cassandra's written in Java. Cassandra has a particular replication model or global multi-data center replication model where they take their ring and they spread it broadly across multiple data centers. We have an opposing model where you take a tight ring and you connect rings together. Another thing is Cassandra uses a column family kind of internal data model structure, so it's more akin to putting up a lot of upfront thought into how you structure your data before you put it into the Cassandra table. RIAK doesn't do this. It's generically unstructured, unless you use documents specifically for searching. There are particular differentiation points, and I'm more than happy to get into it a little bit more offline. Yes, thank you for the question.
Yeah, nobody can design anything that does everything perfectly.
Absolutely correct. It's never going to happen. Anybody who wants to tell you that, just tell them they're a liar and show them the exit.
Yeah.
That's the case. I mean, you're never going to have one system to rule them all. We recognize this, and this is why we particularly integrate with other systems, because we recognize that is just a limitation. What we're interested in, I'll leave you with this. Basho, in my opinion, is distributed computing. And if you look and are familiar with our product kind of evolution from our inception, it has to do with the application of distributed computing to data persistence in different kinds of formats. KV, key value, document, Redis caching, where we do our integrations. How do you make these systems highly available and fault tolerant and easy to operate? So our philosophical kind of underpinning, and one of the places that we compete very nicely, is operational simplicity. There are many stories out there in the field, and I mentioned them, you can do your own Googling, where RIAK simply works. It simply works. I'm not that smart. I don't want to babysit stuff that's hard to use. I really, really don't. And these systems, I mean, we have many customers who go from 5 node clusters and within 12 months, they've gone from 40,000 operations a second to 250,000 operations a second and have grown that cluster by some number of machines and have not added to their infrastructure staff. They have not added FTEs to manage these systems. And this is where the cost comes back in the operational perspective and why OpEx always dominates the conversation versus CapEx for initial development. So with that, I'm going to have to wrap it up to give me the hook.
We're giving you the hook. We'll be out right outside in a few minutes. We just want to thank you again. Did everyone get their stress ball?
No.
Please. Thank you very much.
Thank you guys.
It had a concave ice cube.
So you seeing these kinds of problems, any stuff resonate with you? Sounds familiar? And you're yes, nothing with the line. I'm a master student. Yeah, so mostly you were talking about the US system part of you provide insurance to pharma and insurance companies. By insurance companies, or healthcare insurance companies. Because you know, the phrase today is that there are 5 major insurance providers. You know all these mergers going on. And
merge down the line. Yes, basically the whole revenue function. Right now, I started working
let's get it out. A little bit. And that's what so I get working with you. Yes. Right. Yes. That's exactly So how are we going to go? Oh, me.
No, we're full of chairs.